Hello, everyone. First, I would like to thank Alan Krishley and the organizer of this workshop for inviting me to talk, but also to involve me in the practical organization of the Tropical Phyco-Ecology Coalition, and also to provide some support from the IDEAL project to organize this first workshop. I am Philippe Potin. I am currently the scientific leader of the Seaweed Coalition, together with Vincent Dumézel. And during the last 10 years, I was the scientific coordinator of the French IDEAL project. Since 2017, I started also to coordinate the European Innovation Action, GENIAL. Today, I will talk about what could be done in the context of euchematoid research and to solve some issues this cultivation is facing. I started to be involved in these discussions about 20 years ago, thanks to Alan Krishley. And we discussed at that time with Anicia Hurtado, Jonas Collen, and Sylvain Faugeron about the opportunity to apply for a call for proposal from the European Union in the context of international cooperation. We named our project IDEAL at that time. Unfortunately, this project was unsuccessful for political reasons. I will try to convince you today that the science basis which were behind this project are still valid about 20 years later, and they are still conducting the future of research for around euchematoids, and they will probably provide some solutions to solve the issues this industry is facing today. Today, I will not talk too much about the Seaweed Coalition because it was developed by Vincent Dumézel, but I will try to show you how this new context of for the international coalition will provide opportunities to solve some very important issues in and support scientific cooperation on euchematoids. We are all convinced that we will face a major challenge to demonstrate that the oceans could contribute to solve part of the problem of feeding about 10 billion humans by 2050. We are all working to demonstrate that seaweeds could contribute to solve to tackle this challenge. But to reach that, we will probably need to upscale the current seaweed aquaculture. Nowadays, the tropical red seaweed cultivation is providing more than 15 million fresh tons every year, but it is still produced as a monocrop, either pure cultures of Kappa-Ficus or pure cultures of Euchema or pure cultures of Gracilaria species. But behind this cultivation developments in Southeast Asia, but also in East Africa, like here in Madagascar, the biosecurity aspects are a key issue which is still unsolved. How to secure the provision of biomass for securing the seeding steps, but also securing the culture during the cultivation period to protect them from many diseases on straits which are strengthening the cultivation. Indeed, the FAO provided already the major issues in the euchematoid cultivation, which is some disease which could be induced by some microorganisms, especially bacteria and possibly fungi, which are causing symptoms of eyes. The filamentous algae, which are also epiphytic on Euchema, which are really causing major damages and which are called the epiphytic filamentous algae, EFA syndromes. And they are currently strengthening a lot of cultivation worldwide, and they have conducted to the complete loss of cultivation areas in many countries, including in the Philippines and also in Madagascar and Zanzibar. There is also some other traits which could be caused by grazers, which are also feeding on this biomass and which could be in some areas an important trait. So the symptoms of the diseases, including EFA or IIs, are well described by many collaborators, which provided very nice descriptions of the diseases. And I will not come back to the pictures which were already illustrated by in previous talks, including for the epiphytism, but also for the IIs symptoms on the crops. I will mainly focus on the solutions to prevent these diseases and how to solve the problem of pests in the cultivation. And if we consider the solution which are provided to farmers in terrestrial systems to prevent crop losses from diseases and pests, there is several solutions. Of course, breeding has started to be operated by the farmers 1,000 years ago, and they selected for the best seeding material, and they also learned to select for the best crops which will be protected from some diseases. More recently, the modern agriculture developed the potential of agrochemistry, agrochemicals to kill the pathogens which are causing diseases. And that was the development during the Green Revolution of the uses of pesticides on the cultures. Recently, also some issues related to genetically modified organisms was addressed in the context of protecting plants against diseases. But in the recent decades, the new concept of agroecology developed a lot, and it was linked to some other concepts like the immunostimulations of plants, which could be done by using natural substances, including seaweed extract, which could induce defenses in terrestrial crops. In the context of economy and of farming in the sea, we have less solution available. Of course, agrochemistry and GMO are no way to be developed. Plant breeding strategies started to be developed, but it is still in its infancy in the context of seaweed cultivation. Immunostimulation of the crop were also investigated in the recent years, and a new context of phyco-ecology, which could be compared with the terrestrial agroecology, should be developed for the cultivation at sea. So some farmers are already considering that it could be an important issue to manage the major traits on eukematoid cultivation. Of course, the potential of developing genetic breeding in the context of eukematoid is quite complex, and it has involved a lot of research on the potential to generate seaweed variants through different techniques, which could use tissue cultures, protoplast, the protoplast fusions, but also the potential to develop sexual reproduction in the crops, to develop some approaches which could be related to mutagenesis or pathogenesis or apogamy. I will not develop too much the solutions which were already presented by other speakers, but of course it is important in the way of conducting some selective breeding. I am convinced that in the future, the potential of new genotyping methods, which are now available for seaweeds, but also for, of course, for all terrestrial crops, will accelerate the potential of breeding. Now, through the availability of new generation sequencing methods, we have access to large portions of the genomes, and we are able to generate thousands of polymorphic markers, including single nucleotide polymorphic markers like SNP, but also indel, and then generate a lot of markers which could be mapped on correlated with some genotypes. So it will allow to accelerate the potential for genetic breeding, and it is an urgent need to develop much more genomics around eucomatoids. But today I would like more to stress on the concept of phyco-ecology. And now we can learn from the chemical language of seaweeds to shape the future of the health of seaweed crops. In fact, I was writing 2 years ago in this review from Frontiers in Ecology and Environment that protection of seaweed crops against pathogen, including overgrowth with epibionts, so involving, of course, the epiphytes, competing for nutrients, light, and colonization by pathogens, is a major challenge faced by the intensive monocrop maricultures in East and Southeast Asia. I was also pointing that solutions were already applied, like the uses of HOMPEP, which was already introduced in previous talks, which were shown to alleviate the epiphytism on Carpophycus alvarezi. In the Philippines, some trials which were operated with the Ascophyllum extract provided by Alan Crishley successfully introduces a treatment for alleviating the growth of the red alga Neosiphonia as epiphytes. And it was really demonstrated that it could be a solution to prevent some diseases, including in the context of ice disease, even if it is not shown on this slide. HOMPEP could be really a very important solution, but it is not the sole solution. Considering that the brown algal extract could be active on red algae to stimulate some tolerance to stress, we can also consider that the exudates from the surrounding brown algae, which are growing and in the vicinity of eucuma cultivation, could also provide interesting compounds. It was shown in European studies that some sargassum species release chemicals that act as grazing deterrents and protect crops from herbivores and improve growth. Even neighboring seaweeds, which are not from the same species. So this discovery allowed to consider that we can develop a new context of companion cropping of brown seaweeds with red seaweeds, including in the eucomatoid cultivation context. The example of I provided for the use of HOMPEP and the co-cultivation of sargassum provided me with the idea that introducing some tropical sargassum cultivation lines behind the cultivation lines of eucomatoids could really provide interesting results. Unfortunately, I wasn't able to do some trials with farmers at that time, and I am just developing this concept, which is very close to the so-called push-pull strategy we were used in terrestrial systems, including in Africa in the recent years at a large scale. In fact, this context, which is also called the stimulo-deterrent diversionary strategy, is based on the fact that some volatile chemical could really attract some enemies of the plants and could attract and prevent the attack of the main crop by just keeping them away from the main crop. In the strategy also of push, you can really use also some companion plants which will repel some attackers, and we will attract some natural enemies of the attackers. So of course, all these concepts are not well understood in the marine systems, but we have a growing body of knowledge which is providing new ideas and to develop this concept in the context of eucomatoid cultivation, but also in the context of integrated multi-trophic aquaculture. Sea cucumbers cultivation is developing in many tropical areas. For example, here in Madagascar, it is developing, and it was shown that brown seaweeds such as sargassum could provide interesting feed for these animals. So in this context, we have to think about some experimental designs of companion cropping of browns with red seaweeds. And I have just illustrated here with a few red and brown lines the potential of using the different cultivation techniques for euchymatoids, which could be the fixed of bottom systems, the floating graft, or the hanging long lines, to intercalate or to enclose red seaweed cultivation with some lines of brown seaweeds. I do not anticipate the results of the co-cultivation, but I think it would not be worth to try, and I will encourage any farming company which is interested to develop these systems and these trials to contact me or to be in contact with other colleagues which are convinced that there is a future for these systems. So my take-home message for you will be that genetic breeding is essential to develop the euchymatoid cultivation and to solve especially some issues which are related to biosecurity of this cultivation. We will also need to develop experimental demonstration of companion cropping of brown and red seaweeds. But the question is now where and when. But also that a worldwide cooperation is now required to define a common strategy. I was writing, in fact, these awards about 8 years ago in a Korean meeting, and they are still valid 8 years ago, after 8 years. We need to collect data and information of the expectational needs of people from the seaweed industry about the potential solutions like elicitors or seaweed extract, the characteristic and efficiency of the solutions, the barrier to their development and use. We also need to collect and to try some combination of breeding for disease resistance on immunostimulation solution like the UMPEP solution tried in many tropical areas. We have also to participate in development of innovative tools directed to both professional and scientists, including a guide to standardized protocol for reliable evaluation and good practice. We will have also to display information through a website and publications and participate in the training of both professionals and students. So all these lines are completely related with the context of the Seaweed Coalition and the type of activities we are willing to support within this coalition. So I will thank my co-workers in the Secretariat of the Seaweed Coalition, and I will encourage you to visit our website, as it was already pointed by Vincent Dumézel. You will see how to reach us and how to network within this new coalition, and how you will be able to buy a very interesting proposal that will be supported by our coalition. So we'll be able to provide funding and co-funding your initiative. So I encourage you to apply for the future call for proposal, which probably will release next July. So thank you for your attention. Thank you again to the organizer of this workshop. Goodbye.